Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. The range is just the biggest number, take away the smallest number. Biggest number in this list is 15. The smallest number in this list is 3. So 15 take away 3 is 13. So the range is 13. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3. Then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward one and have that 5 at the end. So the smallest odd number is 3,485. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those. So 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. In this question we're given the output as 53, so we know that the output was 53. So now we've kind of got to work backwards, and when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says +9, but when we go backwards we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way. So 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11. 11 times 4 is 44. 44 plus 9 is 53, so we know we've got it correct. When collecting terms, you've got to collect like terms. So we've got 13x, we've got a 3y. Now they're not like terms, but the 13x is a like term to the 7x. They're both x's, and the 3y is a like term to the 2y. So let's put the x's together. 13 lots of x plus 7 lots of x, and let's put the y's together. 3 lots of y plus 2 lots of y. So altogether we've got 13 lots of x plus 7 lots of x. Well, that's going to be 20 lots of x. And for the y's we've got 3 lots of y plus 2 lots of y. That's going to be 5 lots of y. So our answer is 20x plus 5y. The first thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24, and that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which will be 105, and the final one times 15 is 45 degrees. Add them up and they add up to 360, which is good. They need to add up to 360. So we got our protractor, rest it on the pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210, so we know that's 180 so far. So I'm going to turn my protractor around, and from 180, 210 will be another 30, so I'm just going to plot that on, and then I'm going to join it up. So start at the center and join that up, and we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle, and we're going to look at 105, which will be up here, and then we're just going to join it up with a straight line. And then we're just going to check the last angle, and so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. First thing I'm going to do is just copy down this diagram to the side here, just so we can kind of see what's going on a little bit more. Just extend this a bit. Okay, so the first thing I'm going to do is convert the measurements here into centimetres. So we've got 3,000, 5,000, 1,000, and we've got 6,000. And then I'm going to look at this scale here. Now this says that 1,000 in real life is 1 on our scale drawing. So this is just going to be 3 centimetres divided by 1,000. This is going to be 5 centimetres, 1 centimetre, and 6 centimetres. And then let's draw the diagram. So I'll do 3 centimetres. This is going to be 5, and so it's 1, 2, 3, 4, 5. Got 1 across here. And I'm going to do the left hand one, so 6 down. 1, 2, 3, 4, 5, 6. And then just join them up as it shows on the diagram. And there we go. If you imagine these numbers written out as a list, there would be 5 lots of zeros, so 1, 2, 3, 4, 5. There'd be 9 lots of 1, so 1, 1, etc., etc. Okay, so when we're looking to see the total number of goals scored in the season, we could write them out as a list and then add them up. But a quicker way of doing that is just multiplying the amount of goals by the frequency. So we've got 5 lots of 0 goals, which will just be 0. 9 lots of 1 goal, so that's just 9. 4 lots of 2 goals, so that's 8. 6 lots of 3 goals, that's 18. And then 6 lots of 4 goals, so that's 24. So all we need to do now is add up the 0, 9, 8, 18 and 24, which brings us to 59. So there were 59 goals scored. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here, because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To find the factors of 30, we're just going to write down all the factor pairs, or all the pairs of numbers that multiply together to make 30. So 1 times 30 is 30. 2 times 15, 3 times 10. Now 4 doesn't go because 30 is not in the 4 times table. 5 times 6, and we notice that if we pick 6, it's just going to be 6 times 5, it's just going to be the opposite. So the factors are all the numbers that we've just written down, so it would be 1, 2, 3, 5, 6, 10, 15, and 30. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it would be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. So for this question, we need to understand that the units we currently have are in meters per second, and the units we want to get them to or convert them to are kilometers per hour. Now to convert the meters part is quite easy, because all we need to do is divide by 1,000. And when you divide the top of a fraction by 1,000, all you do is you just divide the whole thing by 1,000. So we're just going to divide the whole thing by 1,000. So we've got 95, and we're going to divide the whole thing by 1,000, so we get 0.095, and that's going to be kilometres per second, because we haven't dealt with the seconds yet. So that's the easy part. The more difficult part is converting the seconds to hours. So to convert seconds to hours, we divide by 60 and then divide by 60. So we divide it by 360. Seems simple enough. But the seconds are at the bottom of a fraction, and when you divide the bottom of a fraction by something, you actually times the whole fraction by that thing. So we're going to times the whole fraction by 360. And so we do 0.095 times 360, and you get the answer of 342 kilometers per hour. So our answer is 342 kilometers per hour. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is, on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. It's really important when answering this question that we're really methodical. So we're going to start off just looking at steak, and so I'm going to start off with the S, and we're going to pair it with the first dessert, which is the I. Then we're going to pair the steak with the second dessert, which is the mousse. Then we're going to pair it with the third dessert, which is the fruit. So we're being really methodical. We've done all of the combinations with steak, and so we're going to look at burger next, and we're going to pair it with the first ice cream, then burger, and we're going to pair it with the mousse, and then finally the burger we're going to pair with the fruit. As long as we do things methodically, we don't ever miss any. So we're going to track the amount of eggs to make the amount of, or to make each amount of omelette. So 5 eggs makes 17 omelettes, and we're just going to find out how much is required, how many eggs is required to make 1 omelette. So we divide that by 17, divide both sides by 17, and so 1 omelette would be 0.294 blah 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 eggs. Next we want to see how many for 67 omelettes, and to get to 67 from 1 times 67, so do that to the amount of eggs, and we get 19.705 blah blah blah. Now you can't get 0.705 of an egg, we always round with eggs, and we always round upwards, because if you need 19.7, 19 won't be enough, so we need to pick 20 eggs. So what we can do here is we can do 3 divided by 7 to find out what 3 is a percentage of 7, find out what that is as a decimal, which would be 0.428 blah blah blah. And then to convert a decimal into a percentage, we times by 100, so we can get that 0.428 blah blah blah, and we're going to times it by 100, and that will be 42.857, and it wants it to the nearest percent, so that's going to round to 43%. The first piece of information I'm going to focus on is the fact Denver gets 8/19. Denver gets 8/19, that means that Engel and Fido together must get 11/19 because they have to add up to 1. So we're only looking at 11/19. I'm going to focus on the ratio next of angle to Fido. So it's 9 to 5. And let's have a look and see, well, first of all, how many parts there are altogether. So 9 plus 5, which is 14 parts. So there are 14 parts in total, and the share that they get is 11 over 19. So what I'm going to do is find out what fraction one of those parts is worth by dividing 11 over 19 by 14. So each part is worth, and I'm just going to keep this into my calculator, 0.041 blah blah blah. And we're asked to find Fido's share. Well, Fido has 5 parts. So Fido has 5 parts, each of them worth 0.041 blah blah blah. I've kept it in my calculator to keep the accuracy, and when I do that I get 0.206 blah blah blah. Now we're asked to work it out as a percent, so I'm just going to times that by 100. So we have 20.676 blah 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 percent, and it wants it rounded to the nearest percent, so that would be 20%. Or actually it would be 21%, because this would round it up, so 21%. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. So we know that the equation of all linear graphs, which we have here, is going to follow the y equals mx plus c. And we need to find out what the m and the c are. So we're going to first of all work out what the gradient is. So that's going to be m. And the gradient is the change in y over change in x. And a different way we can write that is y2, so the y coordinate of the second coordinate, the y component in the second coordinate, take away y1, over x2 take away x1. And so y2 is going to be the y coordinate of the second component, which is there. That's going to be 40, take away y1, which is going to be 31. And then that's going to be over then the x component, so 24, take away 18, which is the x component for the first equation. So it's going to be 9 over 6, which is going to be 3 over 2, because just simple cancelling. So we know that m is 3 over 2, so we can actually just write out that that's going to be 3 over 2x, but we still don't know what the y-intercept is. So what we can do is have a look at the first coordinate, and for the first coordinate we've got an x and y coordinate. So we know what x and y are. So what I'm going to do is just write out the equation I've just written out, but instead of writing y, I'm going to write in 31. Instead of writing x, I'm going to substitute in the 18. So it's going to be 31 equals 3 over 2 times, and the x component was 18 for our first coordinate, and then we've got the plus c. And so all we need to do now is solve it. So there's going to be quite a few components here. We're going to do 3/2 of 18 first of all. So 3 over 2 times 18, well, that's going to be 27. And then we're going to subtract 27 both sides. And when we do that, we get the fact that c equals 4. Now if we know what c equals 4, we can then substitute that into what we know. So it's 3 over 2 x, and we know that c is 4, so it's going to be plus 4. Let's write that in our answer. So 3 over 2, it could be 3x over 2. You could put the x into the fraction, and then plus 4. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2,115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together, 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds, so when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So we're going to start off with x equals 0, and we're going to write out this equation but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2, so it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus, so it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which will be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its 2 decimal places, so that would be 61.19. So you can see here that the triangle has changed size. So the transformation we're looking at is an enlargement. And we need to find out how much it's changed by, so what the scale factor is. And so we've got 2 at the bottom here of triangle A, and we've got 4 at the bottom here of triangle B. And so we are going to times the 2 by 2 to get to 4, so the scale factor is going to be 2. And last thing we need is the centre of enlargement. And to do this, we're just going to connect all of the vertices, all the corners of the triangle, with straight lines. Try and get it as precise as possible. And we've got the bottom left corners as well. And these are just going to be straight lines, aren't they? And we've got the bottom right ones as well, which will just be a straight line going the other way, if I get it perfect. There we go. And so where's the point they all cross? Well, they all cross at this coordinate here, and that is going to be our centre enlargement. So the centre enlargement is going to be at 3 minus 4. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So we're asked to find the bearing of Freetown from Gamley, so that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got a 90 degrees here, we've got a hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434. Blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.